Jump starters are not the same as super capacitors, and still both are current radiators used to help start your battery and your car. What's the difference between them, and why can't you use them for the same thing? I will tell you that, and also how I use them together. Hi Energy Champions, welcome back to Energy Home Do It Yourself. I'm Norbert, Energy Engineer, and today we are reviewing a very popular jump starter, testing its real performance and comparing it with, yes, super capacitors. Does it live up to the specs? Let's find out. This is an intermezzo after the previous experimental video with super capacitors. That was video 86. I thank you for the great interest and many views on my little channel. I saw many comments and thank you very much for all the things I learned from you. There were a few comments that suggested to use the jump starter or lithium as a technology instead of a supercapacitor. This let me think. And I tried to understand why lithium is exactly different from supercapacitors and why they are both suitable for other tasks, like for example jump starting. If the battery is too weak or even dead, that is really awkward and even dangerous if you are alone with your car and there's nobody to help you. My idea with supercapacitors will not save you if the battery is too weak. You need a jump starter, and this one is a spectacular bestseller. But first things first, why don't I believe that a lithium battery can do the same work as a supercapacitor and be connected permanently to the main battery of the car? Yes, it is true. Both are current radiators, but only supercapacitors follow seamlessly the voltage of the main battery, so only they can be continuously connected and always be a no-nonsense partner of the battery. There's no problem if the alternator charges the battery up to 13.2 volt or to 14.4 volt. The capacitors simply follow. And if the battery is weak and, for example, at 12.2 volt, that would be 50% state of charge, it will follow too. This is important because it will give the maximum current at any voltage where the battery happens to be at that moment. And after discharging, come back to the voltage that the battery is able to reach after paying back the current loan to the capacitors. Maybe you remember the short video that I published last week about the comparison of capacitors and in a bank in the case of a mortgage. Lithium and even high power, they have their own voltage, and that is not what you want. They are just in conflict with each other for most of the time. It's like having two gladiators in the same house. Better take a hybrid battery that combines high storage capacity, so measured in ampere hours, and high cranking power, and that is CCA. That means cold cranking amps. These are often a mix of lithium iron phosphate or AGM, and that means absorbent glass mat. These are all batteries and can be combined by the manufacturer with supercapacitors or special designs to handle both high current bursts and deep cycling. I didn't find them. I can also agree with you that a special balancing circuit is better than my solution with diodes. I will probably try those if I can find them, and otherwise I go on with my solution of video 86 with a good compromise between self-discharge and equalizing speed. That was also the subject of many comments, this self-discharge. High-power lithium batteries do have their own application, yes, but it's only on special events, not always that they are connected all the time. And that is if you want to start, but you see that the battery is not able to do it. And because it is so important to have a solution in these awkward situations, I decided to put my focus on it this week. Even if it's not really about energy efficiency, but I got so many comments, and it is so important to ensure your mobility if your car isn't mobile anymore, did I just do it? So I searched for a jump starter that's appreciated by a lot of people and doesn't cost too much. It's the Noco Boost Plus GB40, 12 volt 1000 amperes, that is able to start a car up to 3 liter of cylinder volume if it is a diesel. For gasoline it is even a higher volume. Does this jump starter really contain the 24 watt hour of energy that the manufacturer promises? To test this, I powered a cooler box drawing 3.5 amperes or 42 watts for 30 minutes. That used about 21 watt hours, and this result was after charging my two super capacitor banks. So that's this one that you saw last week, and also this older one with smaller contacts here. So these super capacitor banks were partly discharged, and yes, it was sometimes a little bit violent. So yes, the capacity of this product is okay. But even more important is to start a car in difficulty. You will see that later when I have my camera on my Chevrolet Volt with that battery, that 12 volt battery, not the big one. I checked also another YouTube channel with the name Buy It, Fix It to see what's inside. It turns out that the unit contains 3 lithium cells. Now here's something interesting. The cells are flat and they have an incredible current capacity of 60 C. That means that if the C is 2 ampere hours, then you have a current capacity of 120 ampere. That is scarce for cranking a car. But I suppose that with this short time that is needed to crank a car, the capacity is in reality 160 C, because this product is specified to give 1000 ampere. And second, you can buy this battery, this lithium cell, and I refer to the video where I found it. The creator of the video found this product, so he is entitled to lead you to this purchase. And 3, when the battery is fully charged, it gives a 12.1 volt output, and that's not so much as the old alternative, but that's not necessary. It just means that you cannot, for example, give a stronger boost current into a battery that is already charged, not even half charged. Now here is something that isn't mentioned in other videos, at least those I saw, or even in a manual. You can actually override the automatic mode and force it in manual mode. This can be really useful when the battery is dead. In this mode, the jump starter provides a steady 12 volt without any safety features. You can confirm this with a voltmeter, which will remain at 0 in the automatic mode. Of course, a review wouldn't be complete without a real-world test. I'm going to use this jump starter on a car with a dead battery. So see the next footage for that demo. And no worries, I will definitely show you also the promised capacitor experiment and even more. How do you switch on this hand and manual mode? Well, first you switch it on and then it's in automatic mode. And I don't know how exactly what this is, but it is that all the safeties are in function. So you can switch polarity, it will see if you make a short circuit, for example, if these things are touching each other. But if you want to do your own things and you know what you do, and of course you have also your glasses on your head, then you can push this button. Now you don't see any voltage on the voltmeter, but if you do then this, a long push, then it is 12.2 volts. And then he is just trying, and those 12 volts are really there with big current, with big power. This is the inside of the Chevrolet Volt. You see it, the Chevrolet Volt of the 2012. It's a plug-in hybrid or a range extender. It means that it has a thermal engine, but it is only a kind of generator set, a gasoline generator. And the motor, the drive motor, is only electric. So this thermal motor will only make electricity for the battery. The battery is about 11 kilowatt hour, good for 80 kilometers. Then all the drive, the movement of the car is done with the electric motor. 12 volt battery is dead, but the normal battery, the lithium battery of about 360 volt is good. You see it also on the battery indicator. But okay, we will try to move things up a little bit with the jump starter. So usually if I open the car, then this will glow up, and this will also give some indication, but it's now completely dead. I can push on it, but nothing. I must admit that this is not a real job for this jump starter, because there's not such a thing as a crank motor, which takes more than 200 ampere. It's just a bit of electronics, a bit of pumps and etc. I don't know how many amperes it takes, but okay, we know that he has 12 volt. There's also something to know that if the battery is completely dead, then the automatic mode will not work maybe. So what I do is I put this is the plus. The battery is behind in the car. The voltage they bring to the front side. So this is the plus, this is one plus contact, and here's the ground. It's written also on it. Okay, that's not the car, it's the pump of the house, the water pump. What you hear? Let's see what happens. I don't think anything. Okay, it doesn't do anything because the battery is completely dead. So I must put manual mode. You push this a bit of time, and there it is. It is also semi-automatic because it will try. But anyway, there's now really 12 volt on it. You will see what happens. Oh, that's very good.
这里出什么事了？
Oh, that's my language course. It starts immediately with the motor because it feels that it needs a bit of exercise with the engine. So that's the reason that it's right away starting with the engine. This is 212 kilometers still in the gasoline tank. It is saying 69 kilometers here. It's such a long time that I have not been in this car because it was in Switzerland, and I'm already years now in Italy, and I cannot import a car in Italy because it's a not European car, and that's a little bit strange that they don't admit such a good and beautiful car. I have to take care a little bit with the CO. I will take now the CO meter, CO alarm, and then I will be safe. But anyway, it has been a successful start. It's already 54. So it has been at least 4 minutes. So the motor is warm, and that was all he wanted. Let's see if it starts the engine again if I push it. It should not. So I switched it off now because we tried it, and the motor is now, it's a 6 monthly exercise, and now I want to see how much energy there is still, maybe enough to inflate this tire. This one is a little bit flat, a little bit much. Here it is better, but okay, I will see how it will go. Yeah, this is also quite flat. Here you see the wire which is going from my micro CHP. It's going all the way. I have to fix it, and it's going into the Victron Energy Manager, because this is another house than where the heat pump is, and the micro CHP is here behind this wall. I see that the CO value is also at 0. You see now the degrees Celsius. Doesn't interest me, but I saw that it was 0. So I can stay here, work here, and inflate the tires. So here we have the configuration. We have here the compressor, and it's not so long here. And we put it now on the right one. This contact here, the minus contact, one minus contact is working and the other is just not connected. Just there's a mechanical spring. So there we go. There it is. Okay. Oh, this is. I put it at 2.5 bar. That's the set point. But I measure here. After you set the set point, it goes back to the reading. It's 1.65. So there we go. Yes, it stopped automatically. I will see now how many other tires I can inflate. No, that was the last tire. Okay, we saw that we didn't have enough energy in this jump starter, because it was on only 2 lamps, as you see. And so let me now be a little bit proud about my supply, power supply, because we will do now 2 things with it: giving power to the pump, to the compressor, but also recharge this power booster, this jump starter. I'm proud of it because it gives 30 volt and 10 amperes, and it stays cool. And that was very different in the time when I started to be an electronics student in Eindhoven. Then you had also power supplies, variable power supplies, but they were very bulky, and this one is very light. You can see it, of course, in the description. I think many of you are also the same generation as me. You see, I have white hair. Maybe it's because of the light. But in my time we had this kind of bulky power supplies. I think that you are of my generation because I see on YouTube that many viewers are from age 45 to upside, and I'm also 45 plus. If you are from the same age, you will recognize this fact that these power supplies have changed a little bit, as many other things have changed. If you are satisfied with the content of this video, then I would also ask you if you know enthusiastic do-it-yourselfers which are in the younger phase of their life, that you can share this content with them and say that energy is really a theme of the future. They will inherit the earth, and I hope that I can contribute, show these young persons how to contribute to a safer earth, to energy efficiency in the home. So let's now go on with this experiment and see how this power supply is able for multitasking. I use this USB cable, and it is for 2 ampere, and it is enough for this jump starter. You have here an input, you know it already. USB in, a little bit more light, and now you see it flashing. The second light, which is the last light, it's flashing. So that's in charge, and the other side I put it on 1.12 volt, I put it. And there it is, the indication is 1.55. And you know from the last tire that the set point was 2.4. And then we started. You see that in the description, you see the link to this power supply, to this very cool power supply. It didn't switch on the cooling. Well, you can support me by taking this power supply if you like it. I think it's really multitasker. It does so many things, and you really need it if you do something with electricity. You have also this compressor. I use it quite some times, and it's also a good thing. So you will also find it in the description. It's something that, like the jump starter, you should leave in your car. You should have it in your car. I don't know if you remember my experiment with the super condensed capacitors. Now this is now at 10 volts, a series connection. This will give 12.1 volts. I measured it before you saw it. And now I connected this also again through this rather thin wire. It's only 2 volt of difference. But okay, I still built in this kind of security because this is very strong and this is also very strong. So I just want to see what happens now. Okay, there we go. Yes, we see the volts, and we will also see how quick that goes. Okay, let's do it. Let's see first the green wire, because it will be very interesting. Nothing happens. Okay, there it goes. 11.6 volts. Also the LEDs are quite behaving well. You see them living up. It's now in the automatic mode. I will put it now in continuous. Oh no, I think it is. No, I will try it. I don't know what he is doing now. This doesn't rise anymore. Well, let's switch it off. Now it's 11.3. Now let's disconnect this and put it in continuous mode. So all safety off. Okay. So now what's happening now? It should be in solid white. Okay, we do just connect it. Okay, that goes again. It's doing something. Well, anyway, the voltages seem to be the same here. The LEDs have the same brightness. You see that it goes, the last digit goes between 6 and 8. 7 and 8. And it remains now at 8. So this should be at its final voltage. And it stays there because capacitors, of course, they keep their voltage. I will now try it to put it here directly. Exactly the same. For so little difference, this wire doesn't do much. Doesn't make a difference. But okay, we now learned that this booster gives 12 or 12.11 volt, even if charged, and it's also logical because I understood that it has 3 cells of 3.7, 3.8. That means you can jump start a car, but it is not the same voltage as the alternator gives. Here's now the capacitor bank, and here's again the booster. Here's a resistance wire between, because this is strong and this is strong, and I don't like that too much, and this is definitely much less. So there's 8 volts of difference. So let's see what happens. Oh, that goes up. And it becomes warm, this wire. It is moving, it's really becoming hot. And this goes very quickly. And it smells. And now it starts switching. So that goes a little bit slower now. Yeah, that's warm. I think it has been warmer at the start. Well, this is 20 ampere hours, so it should be able to give 20 amperes during 1 hour. Yeah, I can touch it now. This, of course, is not getting much heat with what it's able to give. Now, I will try now to put it directly. that goes quick. Okay, let's switch it off. And now we measure the voltages. 2.2, 1.9, 2.0, 2.8. That's not good. And the total is 11. So these capacitors are not so equal between each other, and of course they don't have the same circuit. But still, I would expect that well-behaving capacitors more or less would have the same voltage with only one current. The normal sound, it seems to me, of this cool box. So that is half an hour. It is already done. You see that the last red light is blinking. Now the voltage is 0.8. Is that possible? Yes, it's possible. He has written 24 watt hours. So with 12 volt and 3.5 with 12 volt times 3.5 ampere is 42 watt. So this cool box was taking 42 watt, and it says 24 watt hours. So that's indeed more or less half an hour. So I would say it gave the energy together with the older super capacitor which he has been charging. That is, it's okay. We have here two batteries of 6 volt. They are a little bit down. Now they are at 9.3 volt. There's a difference of 2.8 volt. Now I put this in series and I have this wire. This is not very strong, but okay, it will limit the current. We'll just see what happens. Now in automatic, oh yeah, there it goes. Oh, it's working in automatic mode. It's already 12 volt. It is still living. So well, that was a boost, yes. (100 ampere hour). In conclusion, I am making progress on all my projects, even if they sometimes overlap. For example, with the project that I have here. So this a small heat pump from a dehumidifier that I will use for air exchange in your room with active heat recovery. So it's a little bit multitasking. Coming back to this video of today, having both a jump starter and a supercapacitor bank is not a bad idea. They complement each other well. This experience with the jump starter and the supercapacitor helped me understand better the real situation going on in the car and consider to put in the car even a smaller battery or even no one. Just the supercapacitors and, if needed, the jump start. At least I will try how long the supercapacitors will keep the charge if the car is switched down. That is indeed the actual situation with my Chevrolet Volt, which has a dead 12-volt battery. If you found this review helpful and want to support the channel, you can buy this jump starter and also the other devices which are showing the experiments using the affiliate link in my description. You pay the same price as you would on Amazon. They will pay me the percentage, and that helps me to keep making these videos. Thanks for watching and stay tuned for my next video where I finally test supercapacitors in the car. Next week will probably be dedicated to the idea with air exchange and active heat recovery, as many viewers ask me. See you soon.